Recording in progress.
Good morning,
Good
sir.
good morning, sir.
Good morning.
Morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning. Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, Shishir.
Good morning, sir.
Good morning, Vidhi.
Good morning, sir.
Good morning.
Good morning.
Good morning, sir.
Good
Good morning, Shamika. Good morning.
Good morning.
Good morning.
Good morning, sir.
Good morning, Mansa.
Good morning, sir.
Good morning.
Good morning, sir.
So we have got botany sheets one, sir, in WhatsApp group.
Okay, this is soft copy now.
Yes, sir.
Yes, sir, we got the soft
Okay.
copy.
In coming week, they will provide that hard copy also. Okay. I intimated this question, so now they provided that copy. And in next week, I think they will provide that one.
Okay, sir.
Soft hard copy. Okay. Okay, so this is only physiology first, no, or first, second, both? I think only first part.
Sir.
Only first part. Okay, fine. So now you can do your homework also, no? Okay.
Yes, sir.
Fine. Now, just a minute. Let me start the video. Okay. Your chapter is transport in plant. No?
Yes, sir. Transport in plant.
Yes, yes. Transport in plant, osmosis. Then water, turgor pressure, wall pressure, DPD.
Water potential is last.
Water potential, sir.
Yes, yes, water potential. Okay. So what is water potential? This is just osmosis in terms of energy. Okay. Generally, pure water has more free energy. This is maximum. It is called water potential. Actually, this is the difference between two energy. That is called water potential. Two energy means what? The energy of water in pure condition, and the energy in water, energy of water molecules in a solution. Okay. So this difference between two energy, this difference is called water potential. Okay. So generally we can see that the water moves from higher free energy to low free energy. Okay. And this free energy is considered as water potential, and this water potential, it is higher, or you can say maximum, in pure water, and it is 0. When the solute is dissolved, the solution is formed, and the solution has negative water potential always. Okay, it means from higher water potential to low water potential, the water movement. Okay, water moves from higher water potential to low water potential, or from higher free energy to low free energy. Okay, this is water potential. Okay, fine. Before this, someone asked about, I think Pritam was there. He asked about reverse osmosis. No? So what
Yes,
is
sir, yes,
reverse
sir.
osmosis? Actually, reverse osmosis, just a minute. Huh? So reverse osmosis, it means it is just a reverse action. Just a minute. Huh? Suppose this is the membrane. This is semi-permeable membrane. Okay, and this is water. This is solution. In this solution, these are solutes or impurities, whatever it is. It's a solution. Okay. So in this case, what happens? Osmosis reverse osmosis just like osmosis, but in opposite direction. In general, in osmosis, what happens? H2O molecules, they move from dilute solution to concentrated solution. Okay. They move from that solution where solutes are less towards that solution where or towards that area where solutes are more. Okay. So it is dilute solution and the water molecules move from dilute solution to concentrated solution. This is simple osmosis. But a reverse osmosis, in case of reverse osmosis, actually the pressure is applied. Pressure is applied on that solution. Okay. So because of this pressure, osmosis occurs, but in reverse direction. Means now this pressure, it inhibit this entry of water. Okay, it inhibits this entry of water from the dilute solution to concentrated solution. Even it starts or it pressurize the water molecules to move from higher concentrated solution to low concentrated solution. Okay, that is called reverse osmosis. Fine, is it clear?
Yes, sir. In kidneys, the toxins are released like this only, no, sir. They are
This
they
is
are
the process.
concentrated, so water have to move towards the concentrated, so they will apply pressure, so it will come out.
Concentrated to dilute. Yes, this is reverse. One another application in water purification. Okay, so I
Yes,
think
sir.
you are aware of this term RO system. Okay.
Yes, sir. Yes,
So
sir.
that is reverse osmosis actually. So here these are suppose impurities, impure water. Okay. So it is applied in purification of water also. Reverse osmosis. So here pressure is applied in the water filter. What happens actually? The pressure is applied, and this pressure, because this membrane is semi-permeable membrane. Okay, remember this one. So this is the semi-permeable membrane. It allows only solvent, not solutes. So these impurities cannot be transferred from concentrated to dilute. Only the water molecules can be transferred. Only they show osmosis. Okay, so they are diffused from concentrated solution to dilute solution. Okay, that is against the rule. Okay, so this against the rule action, that is a reverse osmosis. The rule is generally water molecules move from dilute to concentrated, but now you are applying the force and forcibly the water molecules are moved. The water molecules move from concentrated to dilute. That is called reverse osmosis. Is it clear?
Sir, can you give
Can
me
you once again repeat? I didn't
Okay,
understand.
fine. Before this, I will repeat that osmosis. Okay. In
Okay, sir.
osmosis, as you know, semi-permeable membrane is required. One dilute solution is required. This is dilute solution. This is concentrated solution. So water moves in general. In general, during osmosis, water molecules, where their concentration, their potential is more. So from dilute solution, they move towards concentrated solution through the semi-permeable membrane. This is normal definition of osmosis. Okay, it is called osmosis. Okay, theoretically it is called movement of water from dilute solution to concentrated solution through the semi-permeable membrane. It is called osmosis. Clear? So solid cannot be moved. Huh? Okay, now they are not movable. Okay, now reverse osmosis. So in reverse osmosis, what happens? You are pressurized. Okay, means you are pressurized the concentrated solution, not the dilute solution. Okay, the pressure is applied on concentrated solution only. Okay, and here the water molecules which are present in this solution. Okay, so these water molecules, they are forcibly, okay, they are pressurized actually to move from concentrated solution to dilute solution. Okay, generally they cannot move. They generally they don't have that tendency to move from concentrated to dilute. Okay, in general it doesn't occur, but forcibly, if you want, then water molecules, they move from concentrated solution to dilute solution. Okay, so this is means unfair, na? You are pressurizing them, you are forcing them. Okay, so they move from concentrated solution to dilute solution. So it is reverse osmosis, na, because SPM is there, semi-permeable membrane is there. So water moves from concentrated to dilute through the semi-permeable membrane. So it is just opposite, just against the reverse, just against the osmosis process, so-called reverse osmosis. Okay,
Sir,
you are
can you
using
give an
reverse
example about reverse
example
osmosis?
of reverse osmosis for water filter. Now, in water filtration, these are impurities. This is impure water, suppose bacteria, other impurities are here, dust particles, okay, and water. So this is impure water. Fine. So this impure water, it is pressurized. One pressure is applied in water filtration plant. Okay, in every city there is a water filtration plant, water filter. Okay, water filtration plant. So here the pressure is applied on this water, that is impure water. Okay, so here the membrane is used, and this membrane, that is artificial, it is not plasma membrane or any, that is synthetic membrane. So here this membrane is used, and through this membrane the water molecules are pressurized to move from concentrated solution to dilute solution. Okay, so in water filtration you can apply this process, reverse osmosis. Clear?
Yes, sir, clear.
Yes. So this is, in simple word, this is the process by which
So root
water
pressure is
moves.
reverse osmosis.
This is reverse osmosis. See, osmosis means what? From dilute to concentrated. This is osmosis. So what will be the reverse osmosis?
Concentrated to dilute.
dilute. So that is reverse osmosis. That's it. Okay. So dilute to concentrated. This is the rule. This is natural process through the semi-permeable membrane. Okay. Through the semi-permeable. This is semi-permeable membrane. Okay. So through which dilute solution, from dilute solution to concentrated solution, water moves. This is osmosis. So what will be the reverse osmosis? From concentrated to dilute. Is it clear? So I will give the definition also here. Just a minute. Okay. This is reverse osmosis. Reverse osmosis. This is the process by which water molecules move from a concentrated solution or impure solution, you can say, concentrated solution to dilute solution, or you can say they're low potential to high potential. Okay, concentrated solution to dilute solution through the membrane, through the semi-permeable membrane. It is, you can say, it works on the same principle as osmosis, but in opposite direction. Same principle, but in opposite direction. In RO or reverse osmosis, the direction of water flow is reversed by applying a pressure that is called hydrostatic pressure. So I'm writing directly hydrostatic pressure, which is higher than
Can you show the definition? This is
osmotic pressure. Okay. So actually in this case, osmotic pressure is there. Osmotic pressure is there. The molecules of solute, they exert a pressure on the wall. Okay, so osmotic pressure is there. So because of this osmotic pressure, water enters from the dilute solution to concentrated solution. Okay, but you have to stop this reaction. You have to stop this action. You have to stop that movement of water from dilute to concentrated. So here you have to apply more pressure. It should be higher than osmotic pressure, no? Then the water molecules are able to move from concentrated to dilute. Okay. So this is a reverse osmosis.
So what will happen if the hydrostatic pressure is lower than the osmotic pressure?
No reverse osmosis occurs. The osmosis starts. Water moves from dilute to concentrated as per the rule. Okay. If the pressure is lower than osmotic pressure. So it means you should apply more pressure on that impure water or that concentrated solution. Okay. In that condition only the water moves from concentrated to that dilute solution. Otherwise again osmosis starts. Okay.
Okay, sir.
So in reverse osmosis, these are 2 points. The pressure will be more than osmotic pressure, and here the reverse action occurs, means concentrated to dilute. These are 2 main points. So you can make this definition clear. So this is reverse osmosis. Okay. Next, yes, water potential. Okay.
Can you show the second point, sir?
Just it works on the same principle as osmosis, but in opposite direction. Okay, now water potential. Okay, water potential.
Sir, we are already done with the water potential yesterday.
I think I only described that one. I didn't make the
But then you
notes.
didn't define it.
Didn't make the notes, I think.
Plasmolysis also.
I just explained that. Explained that. Yes. I explained only. Yes.
Yes, sir, it was explained, but definition was not.
Yes. We didn't make the notes, no? So water
Sir,
potential.
maximum water potential is 0, sir.
Maximum is 0. It is in pure water. Okay.
Okay, sir.
Sir, and minimum
we
is
are-
negative. It comes to the negative side, right?
When it is solution, automatically it decreases. Okay, so it becomes negative. In solution, it is always negative. It is in pure water is there now. If you are adding some solutes, okay, so it becomes solution. So automatically the water potential decreases, and it becomes negative because highest value or the maximum is 0. Okay. Water potential is the difference between the free energy of water molecules in pure water and the free energy of water molecules in a solution. Okay.
Sir, there is
So water
free
molecules,
energy or free of water, sir.
So you missed the word energy over there.
free energy of water molecules is the pure water and the free. Okay, yes. Free energy. Just a minute. This is free energy. Free energy of water molecules. Okay. So free energy of water molecules in a solution. So this difference is called water potential. Okay. It means dilute solution. Pure water has maximum. It is 0. If you are comparing 3, pure water, dilute and concentrated. So maximum in pure water, dilute solution, it is solution. So definitely it is less than 0. Okay. And minimum in concentrated solution because here more solutes are available. So it means this is the decreasing order of water potential. Okay. Means concentration of solution increases, water potential decreases. Okay.
Yes, sir.
Okay. So water moves, water molecules move, water moves from the high water potential or from high free energy level. Water moves from high free energy region to low free energy region. In other words, you can say water moves from high water
Sir, can you
potential,
scroll it up, sir?
just high water potential to low water potential. This is water potential. Okay. A pure water
Sir, gas will have more free energy, right, sir?
in case of gas, liquid and solid, So that is a different point. Okay. But in solution, generally the solution is there because we are explaining, we are discussing osmosis wala process. Okay. So here we use liquid, different types of liquid. Okay, pure water, dilute solution, concentrated solution. So in terms of energy, the water potential is applied in liquid. Okay, the name is water potential. It is not gas potential. Okay, so pure water has maximum water potential. Maximum water potential. It is 0. Okay, it is 0. Maximum. When any solute is dissolved in pure water, a solution is formed. Its water potential will be negative, less than 0. Okay, because maximum in pure water, so obviously the solution has negative value. Clear? Next, water potential, it is generally represented by one sign or letter, that is psi. Okay, psi. Psi. Okay. And the unit to measure water potential, it is bar. Okay, so
How did you write that symbol?
psi.
Can you write it once again?
Hello.
It's a
Yeah,
Greek
sir. Can you
letter.
write it once again?
Like this. Okay. Water
Okay.
potential is measured by measured in, represented by psi. Okay, measured in bar. So the unit is bar. Okay. Now there are different types of
Sir, can
potential
you
in the
scroll up
solution.
once more?
Huh?
Scroll up, sir.
All up one, sir.
Okay.
Thank you, sir.
So there is a relation between different potential. This is water potential, psi m. Okay, and another potential is called osmotic potential or solute potential. Okay, and then pressure potential. So there are main two different potential: solute potential and pressure potential. Okay. Metric potential is also there, but metric potential is not important. It is negligible. Okay, it is insignificant. Fine. So it is not used generally water potential it is equal to solute potential plus pressure potential. Okay, so here water potential is denoted by psi m, sorry, not psi m, psi w. Okay, so this is water potential is equal to psi s plus
Sir, can you scroll some up, sir?
psi p. This is the relation. Okay, psi s means solute potential and p means pressure potential.
Sir, so basically
So in a
potential is
solution,
represented by psi.
potential, yes, water potential or potential, it is represented by psi. Generally water potential. Okay, so water potential means psi w means water potential, psi s means solute potential, and psi p means what pressure potential. What is solute potential? Solute potential, it means this is the concentration of solute in the solution. Okay, concentration of solute in a solution, that is called solute potential. Means it shows that one concentration of solute. So it is shown by psi s. So if you are adding more solute, suppose concentration of solute or concentration of solution increases, it means automatically decreases water potential. Okay, so generally the psi s, it is negative. Okay, it has negative value. Clear? So this is the relation between these three. What is pressure potential? So pressure potential, it is actually one pressure. There is a cell wall is there, no? So this cell and cell content, they exert a pressure on the wall. It is elastic cell wall, no? Membrane and the cell wall. So the content, they exert one pressure on the wall, and that is called pressure potential. Okay, so pressure potential generally it is positive. In general, it is positive. So this is pressure potential. Just a minute. First of all, solute potential. Solute potential, it means it represents concentration of solutes in the given solution or in the solution. Okay. It reduces water potential, because more solute, it means less water potential, more negative you can say. Okay, so it reduces water potential always. More solute in the solution means more negative solute potential. Solid potential. Okay. This is psi s. No? Solid potential. Next is pressure potential. So what is pressure potential? It is actually the pressure exerted by cell content. Okay, cell content means cell materials, the organelles, nutrients. Okay, so the cell content, cellular content, they exert a pressure, they create a pressure on the wall. Okay, and the wall, it creates the pressure on the cellular content. So this pressure potential, okay, means it maintains that that the turgidity, or you can say the turgor pressure of the, or turgor condition. Okay, you can say turgor pressure. So turgor pressure of the cell, that is pressure potential. In short, pressure potential, it means cell content or cellular content, they exert pressure on the wall. The wall, it is elastic, it also exerts another pressure, opposite pressure to the cellular content or cytoplasm or the organelles. Okay, that is called pressure potential. Fine. This
So
is
can you scroll down?
This is a pressure exerted by cell wall, especially wall, not membrane directly, cell wall. By cell wall on the cell content. Its value is positive. Pressure potential is positive in a solution. Generally, it is positive. Okay, and it shows turgor pressure and wall pressure. Fine. So if pressure is applied in pure water or solution, so water potential increases generally, but not much important. Only the 2 points: the pressure exerted by the wall
So
to the
pressure
cellular content.
potential,
Pressure potential is positive in a solution.
is it similar to say wall pressure? So
It represents turgor pressure and wall pressure both. Okay.
Okay.
That pressure. Already we have done turgor pressure and wall pressure. So it represents that. Fine.
yes, sir.
Now, in next, yes, next point, that is plasmolysis. Okay, plasmolysis or plasmolysis. So already we have some knowledge about plasmolysis. Plasmolysis means what? Plasmolysis means when water moves out, comes out from the cell, and the protoplasm is concentrated, okay, and it is contracted, shrink, okay, shrinkage occurs, and it is concentrated at one area, one corner of the cell. That is called plasmolysis. So when a cell is placed in hypertonic solution, this is plasmolysis or lysis. Plasmolysis. When a cell is placed in hypertonic solution, so water moves out, comes out because of exosmosis occurs, and the protoplasm become concentrated. Okay, so this protoplasm become reduced, you can say. It contracts at one corner, in one corner of the cell, and slightly the overall volume, overall size of the cell reduces, okay, because of this process. That is called plasmolysis. Okay. This is this is plasmolysis. Okay.
So once can you show pressure
Sir,
potential,
please
sir?
scroll up.
If one cell it is placed in hypertonic solution, water moves out from the cell and the protoplasm and the protoplasm becomes reduced. Protoplasm is concentrated at one corner of the cell. The protoplasm becomes reduced and is concentrated at one corner. Okay. This process is called, this is called plasmolysis. Okay. This is plasmolysis.
Sir, I didn't understand the point that
Now in
protoplasm-
plasmolysis, actually what happens, there are three different steps. Three different steps are there in plasmolysis. First of all, just a minute, let me show you. This is the cell, plant cell. Okay, so this membrane is, this is the membrane. This is cell wall. The red color, that is cell membrane. Okay, so generally the cell membrane is in contact with the cell wall. Okay, no gap is there actually. So this is a plant cell surrounded by cell wall in general. Now what happens? the plasmolysis starts. Okay, so in this case, just so in this case, plasmolysis starts, exoosmosis occurs, water moves out. Water molecules move out. Okay. So first of all, what happens? The cell size reduces, slightly reduces. Okay, slightly the cell contracts, the cell wall contracts, and it reduces the size. Okay, and this part or this action, it is called limiting plasmolysis. This is the first stage. Okay, so it is not directly concentration of protoplasm or shrinkage occurs. Okay, in first stage, only the cell size decreases slightly. Fine. So cell size decreases. Negligible, I think it is negligible. Theoretically, you can say this is limiting plasmolysis. Otherwise, no exactly plasmolysis is done. So water moves continuously. Okay, and the cell starts shrinking, or you can say reduction in the size. So cell size is reduced. Fine. This stage is called here exoosmosis. Exoosmosis. Then cell starts shrinkage or size starts reducing. Okay, so this stage is called limiting plasmolysis. This is limiting plasmolysis. Fine, this is limiting plasmolysis. This process. Now, in next stage, what happens? The cell wall, the cell membrane, which is in contact with the cell wall, it starts detachment or separation from the cell wall. Okay, at some point maybe it is attached, otherwise detachment or separation starts. So cell membrane starts to separate from the cell wall. Okay, means now you can see a gap between cell wall and cell membrane, and this is protoplasm. Okay, this stage, just a minute, separation of cell membrane from cell wall. Okay, so this separation of cell membrane from the cell wall, because water is continuously coming out from the cell. Okay, so more contraction of protoplasm occurs, and it withdraws the cell membrane from the cell wall. It separates the cell membrane from the cell wall. Means overall the protoplasm, it starts contraction. So because of this, the next stage occurs, that is incipient plasmolysis. Okay, so that is incipient plasmolysis. Fine. Finally, the last stage, in which only the cell wall has its normal shape, but yes, slightly reduced, and the cell membrane contains protoplasm. It shows shrinkage, and finally plasmolysis occurs. Okay, finally the protoplasm is completely separated from the cell wall and it is concentrated at one point. So that process, it is called plasmolysis. This is shrinkage of protoplasm, and that is called evident plasmolysis. This is evident plasmolysis. Okay, so here there are different stages. Okay, I repeat this one again. In the plasmolysis, it is not direct one-shot process. Okay, it doesn't occur in one shot, in one go. Okay, first of all, water starts to move out from the cell, and during this process, slightly shrinkage, slightly reduction in the size occurs. Okay, slight reduction. So that is called limiting plasmolysis. Limiting plasmolysis. Then separation of cell membrane from the cell wall. Okay, generally it is attached to the cell wall, but now there is a separation. So overall, this protoplasm, it withdraws from the cell wall, and now it starts concentration to contract. Fine. So that is called incipient plasmolysis. And then finally, when continuously water moves out, continuously loss of water, so it causes complete contraction of the protoplasm with the cell membrane, and finally the cell membrane is completely detached from the cell wall and it is concentrated at one corner. That is complete shrinkage. Okay, it is called evident plasmolysis. So there are three different stages: limiting plasmolysis, incipient plasmolysis, and then evident plasmolysis. Okay, so these are three different steps. Fine. And finally, complete contraction occurs. This is plasmolysis. Is it clear?
Yes, sir.
Yes,
It's clear,
sir.
sir.
Yes, sir.
Yes.
Yes, sir, it is clear.
Fine. So I'm going to write this part. Okay, just a minute. Plasmolysis ka definition. Okay. Now,
So can you just one show the figure so I'll take a screenshot?
just a minute. Yes.
Sir, the water from even vacuole will be lost.
Yeah. Vacuole is there, but yes, they are completely in shrinkage stage. Okay. The plant cell, the smaller vacuoles, they are disappeared. Okay. But they are concentrated in plasma, in the protoplasm. This is not destruction of cell organelles. Okay, cell organelles are available, but in concentrated stage.
Vacuole stores some water, no sir.
Vacuole stores some water, but the problem is that you are placing the cell in the high concentrated solution. So even the cell which is present in the vacuole, it is also it lost that water also, no? Because most of the water it is present in the vacuole in the cell. So actually the vacuole loses this water, okay, during this process. And one more question I will explain here. Okay, tell me, this is the empty space. Now this is space. This is empty space. Yes. So the empty space is filled by protoplasm, outer water, outer solution, or the water only, which is coming out from the protoplasm. Protoplasm loses water. This is the empty space between cell wall and cell membrane. Okay, a gap is there, no? A gap is formed. So which liquid fills this empty space?
Outer solution.
The water coming out from the protoplasm. The protoplasm, it loses water, no? So it fills this space, or outer solution, it fills the space, or it is just
Outer
a space,
solution.
empty space. It will remain same, huh?
Outer
The
solution.
water,
Outer solution.
Outer solution, why? Huh?
No idea, sir.
The solution.
Sir, I
it
think
remains empty.
there is it possible to the cell membrane again to regain its shape or original shape?
That is a different point. No? This is deplasmolysis. It can regain its shape, no issue. If you place this plasmolysed cell in a hypertonic solution, again water enters the cell. This is endoosmosis. So yes, we'll do this deplasmolysis also. But in this plasmolysis process, an empty space is formed now. So which content is there? It is water coming out from the protoplasm or
Water
outer
coming out
solution,
from the protoplasm.
or it will remain
Outer
as
solution, sir.
outer solution. Why? Any reason?
So because it's hypertonic solution,
Which is that is
the outer
hypertonic.
solution is hypertonic.
It is hypertonic. So if it is hypotonic, then it cannot come inside the cell. The answer is correct, but concept is not clear. The answer is hypertonic.
Exoosmosis.
No, there is no exosmosis, endoosmosis. Only the reason is this is cellulosic cell wall, and the cell wall is permeable,
It has
completely
high
permeable.
potential, sir. That's why.
Okay, we have done permeability. Okay, so cellulosic cell wall is completely free permeable membrane. It can allow solvent and solute both. So the molecules of outer solution, they can move inside the cell wall, but not in the cell. Here, this empty space is filled by outer solution. Okay, this is outer solution. So outer solution enters the cell wall, enters the cell actually through the cell wall, because cell wall is permeable. Okay, it is open gate. Anyone can come here. Okay, so all solution, whatever the material, it enters the empty space. It fills the empty space. This is the neat question actually. So this is one question. Generally they ask a neat. Okay, just a minute. Just a minute. This is cell membrane, sorry, cell wall, and this is cell membrane. This is outer space. So outer space is filled by, sorry, empty space is filled by outer solution. It enters the gap between the cell wall and cell membrane. Fine. Okay. Fine. The plasmolysis occurs, or it is completed
Sir,
in
and
3
what
steps.
about the water that was coming out from the protoplasm? Where does it go?
Now that is because outer solution is also hypotonic. So water comes out from the protoplasm. Okay. In this stage
So it
also,
mixes with the outer
in
solution.
this stage you can see the water is coming out from the structure, and finally because of the higher concentration is here. This is higher concentrated solution. So water again moves out from here. Is it clear? So water generally it continuously is moving out from the protoplasm. Okay, but the empty space is filled by not by water. Water cannot be stopped here. Okay. It moves out from the cell wall because of concentration gradient again. Okay.
Sir?
Now plasmolysis.
This water present in the cell wall, it doesn't enter the cell.
No, water is not present in the cell wall.
No, sir, at the empty space
Ah,
around the cell, it doesn't enters the cell again.
it is not water, it is solution. Complete solution is there.
Okay.
It doesn't enter the protoplasm. Okay,
sir.
because higher concentration is inside the water, inside the cell. Okay, so it is not possible from concentrated, because the concentrated solution, it means what? Concentrated solution, it means it is higher than protoplasm. Okay, already you kept this cell in a concentrated solution. This is highly concentrated solution. It means this concentration is higher than protoplasm always. Okay, so water cannot move enter the protoplasm, shrink protoplasm. Okay, from the solution. Is it clear?
Yes, sir, clear.
You mean to say, if the water is present in the solution, it should be enter the protoplasm, huh?
Yes, sir.
But the
That
problem
was
is
my
solution
point.
is yes, but the solution is highly concentrated. It is higher concentrated than the protoplasm. So even it absorbs from the protoplasm. It absorbs water from the protoplasm. Okay.
Yes, sir.
So
Clear.
that process cannot be stopped. Clear?
Yes, sir.
Yes. Okay. Now plasmolysis occurs in 3 steps. In 3 different steps. It is completed in 3 steps. First, that is limiting plasmolysis. Limiting plasmolysis. It means what? It means this is the first stage of plasmolysis.
The size of the cell is reduced.
Yes, it is reduced. The water starts to move out from the cell and cell size is reduced, slightly reduced. Okay, almost negligible. So this is first. Second, that is called incipient plasmolysis. It means contraction of protoplasm occurs. Contraction of protoplasm occurs, which withdraws the cell membrane from the cell wall.
Can you
From the cell wall. Okay. Just let me finish last point. Just a minute. Incipient and then evident. So evident means this is the last stage. Ultimately, protoplasm contracts and concentrated at one corner of the cell that is evident plasmolysis. The empty space
Sir, can you scroll
between cell wall, just a minute. Between cell wall and
What is the B1's topic name?
cell membrane, or you can say protoplasm.
Even topic.
Plasmolysis, no?
Plasmolysis.
Incipient.
In plasmolysis?
Second topic.
No, I didn't get. Which topic?
Sir, the
didn't get.
subheading of second one.
Yes, sir. The subheading of his second one.
Incipient plasmolysis. B partner,
Sir, show first one, sir.
Shishir.
Yes, sir.
This
B
is-
part.
Yes, incipient, incipient. Incipient plasmolysis. Just a minute, let me finish. The empty space between cell wall and cell membrane is filled by outer solution. Yes.
Can you
I'm
once scroll up?
showing you from this. First step is limiting plasmolysis, second is incipient plasmolysis, and third is evident plasmolysis.
Sir, what is that word after contracts in evident plasmolysis?
Hello? I can't hear you. Be
Sir,
loud. Be loud.
In evident plasmolysis, what is that word, sir, after protoplasm contract?
Protoplasm contact and concentrated. Concentrated at one corner of the cell. I used abbreviation only CONC. Concentrated here. Okay. Concentrated at one corner of the cell. Is it completed?
Excuse me, sir.
Is it done?
Excuse me, sir.
Yes.
sir, B done.
How would be the question asked in the NEET? Means it's filled with outer solution, but the question how would it be stated? Can you once say?
Generally they make direct question. The empty space during plasmolysis occurs and it is filled with, and they will give 4 options.
Okay.
Okay, whatever the options. Yes, so directly options there, outer solution is the correct answer. Okay. In plasmolysis, generally they ask that this question, and one more, what is the plasmolysis? When the plasmolysis occurs, in which situation? So the cell is placed in hypertonic solution. That's it. That is plasmolysis. Okay.
Sir, can you read
Generally,
the
they don't
first
divide
point
in
of
limiting,
evident point?
incipient, and evident.
Sir, can you
Ultimately,
read the first?
protoplasm.
Sir, can you show limiting plasmolysis?
This is limiting plasmolysis. In evident plasmolysis, first point is ultimately protoplasm contracts and concentrated at one corner of the cell. This is the first point.
Okay, sir. Thank you.
This limiting plasmolysis done.
Sir, no, sir.
No, sir.
I made evidence plasmolysis, sir.
I have to complete that portion, at least up to that syllabus. Okay. We have to start plant water absorption also. Okay. Is it completed?
Yes, sir.
It's completed.
Yes, sir.
Okay.
The transport in plants total chapter is there for this week.
No, up to water absorption only.
Water absorptions.
Up to mechanism of water absorption, active absorption, passive absorption. Okay. Fine.
Sir, how many
Next,
absorptions are there in plants?
active and passive, basically 2. Okay, these are 2 different absorption. Passive absorption means there is no requirement of energy. That is passive. Otherwise, in active absorption, you have to use the energy. The plant uses energy. The next term is deplasmolysis. So it is simple. Deplasmolysis means if you place the plasmolized cell in water, pure water or hypotonic solution, So the reverse reaction starts, endoosmosis occurs, and water enters from the hypotonic solution to cell. Now again the protoplasm regain its normal shape and size. Okay, so that is called plasmolysis. Okay, so this is deplasmolysis process. It is the reverse of plasmolysis. When a plasmolyzed cell is placed in hypotonic